Today we'll be learning about continuity. Now continuity can be described and defined by three basic principles. If f of c is a random point in f of x, the function, f of c is defined. Number two, the limit of f of x exists as x is approaching c, and the limit of f of x equals f of c as x approaches c.
This feels like the last
Right. In order for a function to be continuous, one of your requirements must have the limit of that function existing. In order for that limit to exist, your double-sided limit must exist. So, as x approaches that value from the right, it must also be equal to the limit as x approaches that value from the left. For example, the limit of the function is equal to 3 as x approaches 2 from the left, and it must also be equal to the limit of the function as x approaches 2 from the right, and that constitutes a double-sided limit. Here is a visual illustration. Okay, so from the left of 2, x is approaching, or the y value is approaching 3, and it's also approaching 3 from the right side.
I'm explaining that right here. Okay, so for our first part, f of c is defined as basically a point. And for our third step, the limit of f of x as x approaches c is equal to f of c. So what that means, so in this example, c is equal to 2. And when you take the limit of f of x as x approaches 2, it should equal to the point at 2. And as you can tell, when you take the limit from the right and left hand, it will equal to 3. And f of c is equal to 3.
In this case right here, this function is not continuous. Although the limit of f of x as x approaches 2 does exist, and it's 3, the point f of 2 does not exist. Therefore, number 1 is not fulfilled, and your definition of continuity is not fulfilled as well, meaning this function is not continuous.
Here's another example of how a function cannot be continuous. In this case, f of 2 exists. Also, the limit exists. The limit is 3. But f of 2 actually equals 4. So the limit as x approaches c of f of x does not equal f of c. Therefore, the function is not continuous.
Here is another example where a function is not continuous. In this case, number 3 of the definition, or number 2 is not fulfilled, as the limit does not exist, because as x approaches 2 from the left, it is equal to 3, but then as x approaches 2 from the right, it is equal to 4. So the double-sided limit does not exist, and therefore the function, even though there is a point, cannot be continuous.
Baby Kenji, baby Kyle.
Today, we learned about continuity. Calculus is awesome, and I hope you continue to learn with Oliver.